Good morning, and welcome to another wonderful day in the world of chemistry. And I'm your hostess, Mrs. Robinson. Yay! Welcome to my neighborhood. All right, where did we leave off? Oh yeah, that's right. We welcome, by the way, to part 4 of the Unit 2 test review. We'll get there eventually. 15 minutes a chunk is kind of weird. But the rest of this should be pretty smooth sailing. All right, so I'm predicting this one and one more. That's it. All right, so this is all about the lab, FYI. And we're talking about factors that affect basically dissolving something, dissolution. Yeah, the noun, dissolution. And I basically went over three things that can affect that. And the first being surface area. Surface area affects how fast a given amount of solid solute will dissolve. Duh. Why is sugar in like powdery form and all ground up? Exactly. When you increase the surface area by grinding it up, the smaller the size of the particles, faster it's going to dissolve. Temperature. Yeah. The faster the solvent moves, because remember, temperature is basically how fast a molecule moves. All right. And the faster the solvent molecules move, the more collisions there's going to be. And there's a lovely illustration right there. And if you notice, with covalent, with non-electrolytes, it's a lot more dramatic here than it is with with electrolytes. Because electrolytes are what plants crave. Woo, hello. I think I overshot. I did. All right. Which brings us to welcome to the solubility curve. Oh, it's pretty and rainbowy. A solubility curve is essentially, I'm just going to scooch that over. It's a tool. It's a graph, and it describes the effect that temperature has on the amount of solute that can be dissolved. So you notice in this particular graph, we have different types of solute, salts. They're all salts, by the way, if you notice. They're all salts. And we got temperature on our x-axis. We have solubility on the y. Y is up and down. X. And basic rules are as follows. Right there. On the line is saturated. Below the line is unsaturated, and above is supersaturated. Pretty easy, right? All right, so help me out here. Look at question 1 through 4. An amount of solute is given at a specific temperature. If all the solute could be dissolved in 100 grams of water at the given temperature, would the resulting solution be unsaturated, saturated, or supersaturated? So all we need to do is look. And I'm looking. We're looking at KCl, which is this blue one right there in the middle. And it says 60 grams of KCl at, so what it's giving us is it's giving us the y-axis first, x-axis second, and it wants to know what is its state. Alrighty then. What you got? I'm going to give you a little bit of time before I do it. All right? Line it up. Yes, I'm playing in PowerPoint here. All right. So we got what? We got 60 grams. That is right here. Hey, what happened to our line? There he is. Okay. Get off of there. All right. So 60. Whoop. Right there. Hold on. Let me bring down the other end there. I'm going to do this for this one for the sake of time, and then we can do the rest without the line stuff. Okay? This is just to prove my point. All right. 60 grams at 70 degrees, where the 2 points intersect. Right about there. Using our little teaser up here, what do we got? Well, in the case of KCl, it is above the line, right? I see above the line, which means what? Appropriate wait time. You went over. Super saturated. Bam. All right, do 2, 3, 4. Boom, boom. All right, 2. What do we got? I got 10 grams. That's way down here. KClO3 at 60 degrees. Boom. To me, that says unsaturated. Perfect. 80 grams of sodium nitrate. Way up at the top. Got this nice red one. Yes. 80 grams at 10 degrees. Boom. I don't know about you, but that looks like it is on the sweet spot. It is saturated. And last one, calcium chloride. That's the orange one that's doing the whoop-de-doo, going way up. And we got 70 grams at 20 degrees. And again, pops it over into the unsaturated territory. All right, everybody got a feeling now for solubility? Me too. Okay, so try it again. Draw a conclusion based on the solubility curves of which compound would have the greatest percentage recovered after cooling a saturated solution of that compound from 90 to 30. Okay. So we're going from 90 to 30. I just wanted a thicker line. All right, let's see. 90 to 30. Oh, that's a pretty good guess, Mrs. Robinson. Thank you. I thought so too. So what we're doing is asking for the greatest percentage recovered. So translation, yeah, I know, you're wondering, what's the translation? Translation is steepest curve. And in this particular scenario, where's the steepest curve? I know you might be thinking KClO3, but no, just wait. Look at KNO3. Yeah. Do you see it? The green line. Who's got the steepest recovery? Icano. It's KNO3. You can know too, right? Exactly. All right. So, again, little tidbit, last little hint from Mrs. Robinson is this. If it is a solid, as you know, solids and solvents, as you increase the temperature, you increase solubility. We proved that with our little salt pellet. However, did you know that if it's a gas in a solvent, temperature actually has the opposite effect? So think about a soda when a soda's warm. That's what I want you to think. When it's a gas into solvent, think of, that Dr. Pepper. Think of that Coke. And when it's hot, bleh. It's gross, right? Totally gross. All right. Last thing we're going to cover, molarity and how to calculate it. And I'm going to save that for part 5. Thank you for showing up for part 4. I appreciate you. And I will see you for part 5.